Hey, it's Ahmed here from Radi Electrical, and today we have put together a short presentation about RCDs, also known as safety switches. In this presentation, we will cover the following. What is an RCD? How does an RCD work? The different types and styles of RCDs, the difference between an RCD and a circuit breaker, where and when are RCDs required. We'll go through the testing requirements of RCDs, and we'll conclude with some notes and tips on RCDs. So let's get started. Okay, so what is an RCD? Firstly, an RCD stands for Residual Current Device. What does that mean? As per the Australian Electrical Standards AS 3000 2018 definitions, an RCD is defined as a device intended to isolate supply to protected electrical circuits, socket outlets, or electrical equipment in the event of a current flow to earth that exceeds a predetermined value. Safe Work New South Wales defines an RCD as a residual current device or safety switch protects you from the most frequent cause of electrocution, a shock from electricity passing through the body to the earth. It can also provide some protection against electrical fires. So, put simply, RCDs are electrical safety devices designed to immediately switch off the supply of electricity when a leakage to earth is detected at harmful levels. They offer high levels of personal protection from electrical shock. So that is what an RCD is. So how does a safety switch work? Firstly, let's go back to Year 9 science class on the basics of electricity. Put simply, electricity flows from the active and returns to the neutral. In a common normal state, the amount of electricity that flows from the active must equally return to the neutral. So that's the flow of electricity 101. So now how does that apply to a safety switch and how it works? Simply, a safety switch is a monitoring device that monitors the amount of electricity flowing in and out of a circuit. It does this by a device called a differential current transformer, which is found within the workings of an RCD. Most common RCDs are designed to turn off within 300 milliseconds when a difference of 30 milliamps or less is detected. Remember, 30 milliamps is still enough to cause serious injury or harm. In a normal state, the flow of electricity between the active and neutral conductors should always be equal, as we learnt earlier, and therefore a difference of 0 should be detected by the safety switch in a normal state. Now, let's see what happens in the event of a fault. Let's say we have a circuit that at normal operation has a current flow of 6 amps. But today, one of the light fittings on that circuit has a fault in it, and the cable inside the light fitting has burnt off and is touching the metal frame of the light fitting. So now there will be a difference in current flow between the active conductor and the neutral conductor. The RCD will within 300 milliseconds detect this and trip out the circuit. So that is how an RCD works in simple terms. Okay, let's discuss the different styles and RCDs that you may come across. Firstly, this is probably the most common RCD that you'll come across if you haven't come across this at your own home. These RCDs are just a standard single pole circuit breaker and RCD built into one. So the giving sign of an RCD is you're always looking for a test button on the device. That's what gives it away that it's an RCD. Where as a circuit breaker, these don't have these buttons. So that's a single pole combo RCD with a circuit breaker built into one. That is just a circuit breaker on its own. So always look for that test button. These are normally found in residential or smaller block of units, maybe inside the individual units. You'll find this style of RCD combos. Once we move up to a slightly bigger commercial site that have larger switchboards, you'll find this style of RCD, which is sometimes called a Mod 6. These are normally found inside the bus boards, inside them. They have a tail which you wouldn't see because this will be inside the board behind the cover, you won't see that. But that's a 3-pole RCD, so that controls 3-phase circuits, and this controls single-phase circuits. These are both RCD CBs all combined into one. Same thing, as you can see, we've got test buttons. So test buttons always give away that it's an RCD. The next ones are more frequent in commercial older sites. These are designed to fit in older, larger switchboards, and that's hence why they're designed in this shape to cover the space required. So these are also combined RCDs and circuit breakers as one. And same thing, as you can see, there's a big red button called test. There's another little yellow button with the words test next to it. That's the giving sign that it's an RCD. So these will be found maybe at schools or even older sites that have older switchboards. You'll find this style of RCDs. Okay, so let's discuss the difference between an RCD and a circuit breaker. It is very important to understand and differentiate the difference between an RCD and a circuit breaker. So, an RCD, residual current device, is designed to immediately switch off the supply of electricity when electricity leaking to earth is detected. A CB, circuit breaker, is an electrical safety device designed to protect an electrical circuit from damage caused by an overcurrent or short circuit. So, put simply, an RCD is designed to save life to ensure a circuit is interrupted and turned off immediately within 300 milliseconds, and in most situations a current of no more than 30 milliamps. But a circuit breaker, on the other hand, is designed to protect electrical circuits from overheating and short circuits, which can cause a fire. So they are both devices designed to protect, but as you can see, one is intended to protect human and other living things, and the other is to protect the cables and infrastructure providing the electricity. In most circuits, if it is protected by a safety switch, it would also be protected by a circuit breaker, and this can be found in two forms, either as two separate units or a single unit combining the two protection methods into one. These are usually referred to in a number of ways. Some are RCB, RCBO, or RCCB. Okay, so let's discuss where and when will we require RCDs. The Australian Electrical Standards AS 3000 2018 section 2.6.1 states that the use of a fixed setting RCDs with a rated operating residual current not exceeding 30 milliamps is recognised as providing additional protection in areas where excessive earth leaking current in the event of failure of other measures of protection or carelessness by users could present a significant risk of electrical shock. RCDs with a minimal residual current of 30 milliamps are now required for final subcircuits rated 32 amps or less that are supplying socket outlets, lighting circuits, direct connected handheld equipment, and direct connected equipment that present increased risk of electrical shocks. So, as you can see, most electrical circuits should be protected by an RCD. If you're not sure, you're better off checking with your electrical contractor to check if it is required or not. Okay, let's discuss testing requirements of RCDs. So as we know, RCDs are designed to save lives, and therefore it is critical and mandatory that we ensure that they are operating correctly. Division 6 of the Work Health and Safety Regulation, section 165 states that a person with management or control of a workplace must take all reasonable steps to ensure that residual current devices used at the workplace are tested regularly by a competent person to ensure that the devices are operating effectively. It is also important to understand the definition of a workplace. Safe Work Australia defines a workplace as any place where work is carried out for a business or undertaking, and includes any place where a worker goes or is likely to be while at work. This may include offices, factories, shops, construction sites, vehicles, ships, aircrafts, or other mobile structures both on land or water. In addition, the person must ensure that a record of any testing carried out is kept until the next test or the device is permanently removed or disposed of. A record of testing must specify the following things: the name of the person who carried out the test, the date of the test, the outcome and results of the test, the date on which the next test must be carried out by. So, how often do RCDs need to be tested? New South Wales Safe Work advises that the frequency of inspection and testing will vary depending on the nature of the workplace and the risk associated with the electrical equipment. It is important to work closely with your competent person to ensure these requirements are met and all RCDs on your site are in working order. There is no point having RCDs to protect life that simply do not operate correctly. So let's conclude it all. Firstly, RCDs are designed to save lives. Always remember that when dealing with RCDs. There is a difference between an RCD and a circuit breaker. Save a life, protect the cables and electrical infrastructure. This will not protect life in most situations. This is designed to save lives. Next thing, RCDs. Yes, they can be a nuisance, especially when we have tripping and when we can't determine exactly where the fault is. Because they pick up on very minute faults, they can become annoying and tripping all the time, especially with outdoor lighting circuits. We find this a lot. And one of my biggest pet hates is when I find lazy electricians that don't want to find the fault. They will replace an RCD with a circuit breaker. And unfortunately, in my experience, most of the time I find people will not be able to tell the difference. All they care about is, hey, my lights are back on. I don't need to deal with those phone calls anymore. But always make sure that if there is an issue, spend the time, find it, because normally RCDs are giving you an early sign that you do have an issue within that circuit before a circuit breaker trips. Because normally when a circuit breaker trips, the fault is a much greater fault. So that's another one there. Testing is also another one that's important. To be requirements based on your role that you're responsible to ensure that these devices are operating correctly. And what's the point of having a device designed to save lives if it's not working correctly? So if you're not sure or you have any questions, please feel free to either reach out to your electrical contractor and ask the questions, or you are more than welcome to send us an email or find me on LinkedIn and send me a message, and I'm happy to help you out wherever we can. Always remember, always reliable, always ready, always Radi. Thank you for your time.